All right, so we're going to go ahead and start with this problem, which is similar to what we left off with last time. And notice that the difference here is that we have these numbers. This is called a definite integral because we have a definite beginning and a definite ending. It's still an integral. So we're going to answer the first question. Is this a basic one or a more complicated one? Basic one. We're not going to do U substitution. This is a straightforward one. So let's put the numbers on hold for now. Let's just make sure we do the integral correct. So the 6 stays, we add 1, divide by it. Minus 2, the 2 stays. This is a 1, so it's x squared over 2. Don't forget your plus c. And this simplifies to 2x cubed minus x squared plus c. So let's pause there and make sure we did the integral correctly. Now we're going to deal with those numbers. So what I'm going to do is I'm going to take that integral and go from -3 to 2. So how do I do that? Well, you plug in the top one first. So this is going to be 2 parentheses 2 cubed minus 2 squared. Now, you can put the plus c, no worries at all. But you're going to notice I'm not putting the plus c at the end because we're going to have a c minus another c. It's going to go away anyways. But if you want to put the plus c, you're more than welcome to. Some people worry that they're going to forget to put it when they do the normal integrals. Up to you. But I know c minus c is 0. Then it's always upper minus lower. Then we're going to do the lower one. Notice I'm being very careful to put it in parentheses, because a mistake people make is they something with the sign, something with the order, some sort of mistake. So be very careful when they do that. So I'm going to do one at a time. The first one is 2 parentheses 2 parentheses raised to the 3 minus 2 squared minus 2 squared. So the first part becomes 12. The first part becomes 12. Minus, now again, be careful. Be careful. When I plug this in, we're going to plug in -3. So I'm going to do 2 parentheses, -3 parentheses, raised to the 3rd, minus parentheses, -3 squared. If you type it in wrong, it's going to come out wrong, and you should get -63. -63. So this actually simplifies to 12 plus 63, and 12 plus 63 gives us an answer of 75. So the answer we get by hand is 75. I'm going to give you a minute and look at the original, type in the original in the calculator, and make sure you get 75. Remember, when we check it in the calculator, we just put in the original. So we're going to go to the calculator at the home screen. We're going to press math, number 9 for integral. The lower bound is -3. The upper bound is 2. And then we plug in the original question, which was 6x squared. 6x squared minus 2x. Don't forget the x at the end. Again, every calculus is a little different. If yours just says integral, you're going to put the function 6x squared minus 2x comma x comma lower -3 comma 2. It will still work out and you'll get 75. Okay, so that problem is a review problem. What we did last time. We're going to take that problem and I'm going to add one extra thing, the last thing we're going to learn in chapter 5. And what I'm going to say is, what if instead of asking for the integral of from -3 to 2 of 6x squared minus 2x, I asked for the average value. I asked for the average value. Please understand, when you take the integral, you go from a rate of change to total. So this one's not really a word problem, but 75 would be the total. 75 would be the total. And if I add that little extra word looking for average value, average value? Well, I want to take that and let's think about it. If I went from -3 to 2, be careful, say it out loud. What's the distance from -3 to 2? 5. Perfect. So some people are like, oh, you subtract them, you add them. It's a distance, right? So from -3 to 2 is a distance of 5. So I did this integral over 5 years, interval of 5. It's not a word problem, but you're going to get the idea. So the only thing we have to do is, if you want to find the average, divide by 5. So where did the 5 come from? It's the distance between the two. It's the distance between the two. And I'll explain that a little bit better once we get to the next problem, because it's a word problem. But just understand, if it says average and the interval was over 5, at the end, you divide by 5. So 75 divided by 5, and you would find the average of 15. Now, again, this is not a word problem, but this would be like 15 per year, per month, whatever it is. But this would be the average. So all we're really learning is, if it has the word average at the end, you divide by the interval. You divide by the interval. Okay. Now, again, they have a formula, B minus A. So if I follow that formula, 2 minus -3, 2 plus 3 is 5, you get the same answer. That's like the formula. And you divide by it, it's on the bottom, but you just divide by how many years or whatever it is. So that's the actual lesson. Now we're going to put it to practice with a word problem. So this one says, given the supply equation, so we have S of X equals 10e to the 0.05x. Find the average, there's that word, price over the supply interval from 25 to 30. So this is where we can kind of put all the pieces together. So what's given to you is a rate of change, and we want to work backwards to find total. So that means we're going to take the integral of 10e to the 0.05x dx. So we're taking the integral. Okay. Integral will give us total. Integral will give us back to total. But I don't want the total over all time. I want the total from 25 to 35, starting at 25, ending at 35. So hopefully now those numbers have a little bit of meaning. This is your lower bound, upper bound, where it starts, where it ends. And I'm going to pause there and ask you to give that a try. And I'll tell you that this is going to be U substitution. Why is this going to be U substitution? Because we know how to do e to the u, but we don't know how to do e to the 0.05x. So that's a little hint. Okay, so it's going to be U substitution. Be careful. Check it in the calculator. Don't worry about the average part yet. Get the answer. And if you want to try, if you get the answer, check it in the calculator, then incorporate the average part, understanding we're going from year 25 to year 35. So this one ends up being a little more complicated because I don't know how to do e to the 0.05x. So if I decide that u is 0.05x, and we take the derivative of u with respect to x, we get 0.05. Because we've done several of these, we know that you always get dx equals du over 0.05. Now, it's all about the details, so be very, very careful. So we'll worry about the numbers later. This is the integral of 10 e to the u du over 0.05. Notice I have not taken the integral. I still need to take the integral, but I'm going to simplify a little bit. 10 divided by 0.05. So if I go to my calculator, 10 divided by 0.05, that will give you 200. Integral 200 e to the u du. Again, I have not taken the integral yet. I keep writing the integral until I actually take it. And when you take it, the 200 stays in front. The integral of e to the u is e to the u. Don't forget your plus c. And we don't want it in terms of u, so this will be 200e instead of u, 0.05x plus c. So let's pause there. Did we get the integral correct? Let's deal with the numbers. Now remember, you can put the plus c if you want, but we know that we are going from 25 to 35. So I'm going to do 200 e to the 0.05 times 35. I'm not going to put the plus c because I know it's going to subtract out, but if you want to put the plus c, you can. Minus 200 e to the 0.05 times 25. Now that we understand the concept, the other mistake people make is they type it in wrong. They try to do too much. I try to do step by step. So I'm going to do just the first part, and I'm going to be careful. So this is going to be 200 e second ln raised to the 0.05 times 35. Now again, know your calculator. Some calculators, you got to keep the parentheses in there. It all depends on your calculator. But you should get about 1150.92. 1150.92. Now remember, our goal is we're going to get total price. So since it's a price, I'm going to do 2 decimal places. Okay? Our input is supply, our output is price. Then I'm going to repeat that. 200 e to the 0.05 times 25. And that's going to give us 698.07. 698.07. And I'm going to subtract those two numbers. 1150.92 minus 698.07. Hit enter, and we get 452.85. Now, if I had stopped there, that would be a great answer if I was looking for total price. So if I was looking for total price, that would be the final answer and we'd be done. But this one didn't ask for total price. This one specifically asked for average price. When it has that little extra average price, okay, I found the total price from 25 to 35. But if I want the average price, I would have to take my total answer and divide by what? Perfect. You divide by 10. Why 10? What's the distance from 25 to 35? It's 10. Yes, you can do 35 minus 25 and get 10, but just so you understand, it's the distance between them. So be careful if it's a negative and a positive. And when you do that, you find the average price, which will be $45.29. That would be the average price. And with that, we're done. So there's one application that fits well in this chapter. So I'm going to go over this. So we remember that when you start with position, and you take the derivative of position, you get velocity, rate of change. And if you take the derivative of velocity, you get acceleration. And that was our second derivative. So again, to go from position to velocity, you take the derivative. So for example, if position was how many miles away you are, velocity would be miles per hour, and acceleration would be miles per hour squared. But you take the derivative. Well, we just learned something called integral, which is antiderivative. So how do you think I would go from acceleration back to velocity? You would take the integral. And if you go from velocity to position, you take the integral again, okay? But we know that when you take the integral, you always end with a plus c. Then you got to figure out what that c is. So that's what this deals with. So this one says, if a stone is thrown with an initial velocity of 20 feet per second, find the velocity function. Hint, velocity is 20 feet per second when the time is 0. So time 0 when the velocity is 20 feet per second. So that's a hint, that's a given. So bottom line, and then after we determine it, determine how fast and what direction we'll be traveling after 6 seconds. So worry about that next. Step 1, we're starting with acceleration, but what I want is to find velocity. So how do I go from acceleration back to velocity? Take the integral. Perfect. So you're going to take the integral of -32, be careful, with respect to t, not x. T stands for time. And I'll give you a hint. When you take the integral, be careful, it's a basic one, but sometimes it trips people up. You're going to end up with a plus c. You got to figure out what the plus c is, but conveniently, I gave you some information to find c. Bottom line, when you're done, you should have the complete velocity function, including what c is. Give it a try. So be careful. Sometimes it's the basic ones that kind of trip us up. If you're taking the integral of -32 or any number, this is going to be -32t. Don't forget your plus c. And again, we're going from acceleration to now velocity. So you have your velocity, but there's an issue. The issue is we don't know what c is. So you must be given, I called it a hint, but you must be given some information about velocity in order to find c. So when the velocity is 20, the time was 0, and now I can solve for c, because you're going to get 20 equals 0 plus c, therefore c equals 20, and now we have our complete velocity function, which is -32t plus 20. Now that we have our velocity function, I can go back to that question. The question says, determine how fast and in what direction will it be traveling, velocity, after 6 seconds. So I'm going to plug in 6 into my new equation. And we want to find the velocity after 6 seconds. So if I put -32 times 6 plus 20, we get -172. So you're like, wait a minute, -172. Okay, so first of all, we got the answer. Secondly, we need to figure out what it means. First of all, remember, this is someone throwing a stone into the air and the stone comes back down. First of all, its velocity. What are the units going to be? Feet? Feet per second, or feet per second squared? Feet per second, because it's velocity. Now, if I was going to write this in a sentence, I would put at 6 seconds, the stone's velocity is 172 feet per second, but I avoided the negative. What does the negative mean? Good. It means downward. And you're like, how is that possible? Well, remember, there's a person throwing a stone in the air. So 1 second, 2 second, 3 second, 4 second, 5 seconds, 6 seconds. That stone is now going downward. Negative means downward. How fast is it going? 172 feet per second. Okay, so take a minute, look at it from start to finish. We're about to do another one off of this. Any questions on this? Now, we went from acceleration to velocity. The second part of this question, we're going to start with velocity. So velocity was -32t plus 20. and I want you to go backwards to position. Again, they have to give you a hint. They tell you that the time is 1 second when the position is 19 feet. You need that hint. Then that's going to help you. I'm not going to say anything more than that. We'll see if you learned it. Then you're going to answer the question. Once you have the full complete position function, what's the position after 2 seconds? And write in a sentence. Now, the only little caveat before you get started, if you messed up the first one, you can't do the second one, because this is all based on the first one. So if your first one's wrong, your second one's going to be wrong. So you got to be very careful that your first one's correct. So we're going to follow the same process as we did with the previous problem to this problem. So we want to go from velocity backwards to position. So we're going to take the integral of -32t plus 20 dt. Again, if you want to start getting good with your symbols, every time you have an integral, you got to have that dt or dx, whatever the variable is, they go together. Once you take the integral, it's gone. Okay, so technically, if you didn't put dt, it's wrong. Got to have that with it. It's part of the notation. Then we have -32t squared over 2 plus 20t plus c. This is our position function in relation to time. -32 divided by 2 is 16. T squared plus 20t plus c. Now, we have our position function, but there's an issue. The issue is we don't know c. So they have to give us information to find c. They tell us the position, which is where we're now at, the position function. When time is 1, the position's 19. So position is 19 when t is 1. So everywhere there's a t, you put in 1. So 19 equals, this is -16 plus 20, that's 4. -4 minus 4, c equals 15, which we now end up with our complete position function, which is -16t squared plus 20t plus 15. We'll pause there, make sure we got the complete position function before we plug anything in. Thanks for catching a little typo, righto, right there. Thank you. So it's -16t squared plus 20t plus 15. Now that we have that, we want to know what's the position after 2 seconds. So if we plug 2 in for t, again, a lot of times the mistake is just plugging it in. The work is correct, but the answer is wrong. So be careful typing it in. If I go to the calculator, okay, so we have -16 2 squared. Again, being careful to type it in correctly, plus 20 times 2 plus 15, we get -9. Now again, what does that mean? Well, remember, we're talking about position. So would this be feet per second, or feet per second squared? Feet. So at 2 seconds, the stone's position is 9 feet. How do you explain the negative? It's not direction. Good. Below ground. What does that mean? That means we have this person throwing a stone. This is 0. It goes up, it goes down, and after 2 seconds, it's 9 feet below the ground. It's 9 feet below the ground. Okay? And with that, now we are done.